waiting for the 3 to come around. 3's there. Got a little dab of lube there. And in and out. Back to 0. We're going to go ahead and drop it to 5,000 cuts now because it is a fine thread. If you break an insert or gall up a tool bit near close to finish there, you know, it's not always pretty. Another 5. We're waiting for the 3 to come around again. It doesn't have to be the 3, it could be the 4, 1, or 2 also. The 3 just happens to be the next nearest, and there we go. You can cut threads at a faster speed than this too. You just got to be a little quicker, okay? Now, as long as you don't ever disengage your feeds or your increments from the main spindle drive, you can speed up your threads, okay? Go here like this. You can come in here. Here's another 5. Okay, here's coming in. Holding the same spot, and we didn't disconnect our feed from our speeds there. We didn't change alignment there. Okay, there's 41. We're going to take this cut, and then we're going to take a spring cut, and then we're going to check it with a nut, and then we're going to check it with the PD wires. Okay, we're going to pull this out to check this thread, and one thing you got to do, you got to mark where your dog goes so that if you have to go back in, you know exactly where to put that dog at and keep in time with your threads. It's the only difference between threading with a dog and threading with it clamped into the chuck. Alright, our nut screws on there. Our lock nut screws on. And it's getting tight just like it does on the original one, so that still is feels good. Alright, now let's go ahead and mic that with the wires. Alright, now I'm going to put it back in here because sometimes you have items in the lathe and you need to mic them right in the lathe there that they don't get removed. So you have to gauge the threads right in there. You did your test on there, now you need to check it, see how much more you need to go. Alright, we're going to move a few things out of our way here, just because it's convenience and we can. If you had to do something, you had to keep cutting, you can't be removing your items there. Alright, on number 16 threads here, it says use 040 wires and add 2528 on it, okay? So, you know, I had a couple friends there. One named Billy was one of my better friends there in the machine shop there, and he used to have a piece of he put 2 wires in a piece of tape all the time at the end here so they would hold it. But you know, everybody has their own way about it. And it's kind of like, it's almost like holding chopsticks. And now it says the diameter plus 25, so we know that we're going to be somewhere around 775. I kind of just get the mic real close to it. But once you got the anvils on there and they're straight across, it is pretty easy to keep them in there. And the reason why you kind of hang on to them is because they do drop out, and if you got a whole bunch of chips in your pan, alright, now it said add 25, and we actually are about 23 and 9/10, 24. So we're about a thousandth under from what the thread chart actually tells us to do it, and you know, that's that's pretty close by my method using my dashboard gauge. And it's all about the feel of the individual nut that you're putting onto your item there. So you know, this is a good way to know. If I didn't have either one of these two test nuts, I would refer to using the wires. So when, you know, in the past, I like that. And keep commenting. If you don't see something, give me a comment. I'll probably drag it out, and I'll probably tell you why I do or why I don't use them for that instance. But most of the time on threading, I've been doing threads for so long now, you build up the feel. It's a feel. I purposely drug out my wires again, and I put the shaft in the mill vise here and put the wires on here, and basically show you so that you get a good glimpse of how you can rock these wires, and you get the high and low, or the major high. You want to make sure you're side to side, because you are resting on 2 pins on the top and that one single one on the bottom, and you want to slide back and forth so that you get the highest point of that. Okay, and right there, I'm reading about 775 there, but I did have, remember it said 25 thousandths or so over, but I'm at like 24, so I might be a little light on the actual diameter by about 1,000 or so, but I'm well within the range of a quality thread in my mind. Alright, so I felt bad that you couldn't see it actually in the lathe, but there you go. Alright, this original shaft has got a press-in Zerk fitting, and we're going to go ahead and we're going to put in a screw in, and this is 1/8 thread. I don't have any of the 1/4 28 Zerks, and I'm going to go ahead and, so this is a Q drill, and then we'll tap it. We're in there far enough now to where I don't need the steady rest in there. Now the general rule I find on the depth of a pipe tap is almost 3/4 of the full thread length there on the tap. Gives you a good fair tap depth and fit for a plug or a Zerk. I like that. Okay, we're coming in here. We're gonna get set up on here. We need to know edge and center of this part here, so we're in relationship to the spindle. So that's what we're setting up right now. That's just a wiggler or edge finder. Alright, there's equal to the edge. And 3/8 will be center. Right there. Alright, we're going to call that center. By eyeball, it looks like center. Okay, first off we're going to go for the hole in the end here, and that is it's a 1/4 inch in from the line there, and we'll go from there. Mark that 0, 250 right there. Alright, now, I'm going to get some air here. I'm going to blow this off. Okay, now basically, the Woodruff keys are in line with that. So we're going to rotate this around, and we're eyeballing that drill bit. Kind of level right there. That looks good. Alright. Now we're going to change out our chuck to the collet, because we're going to come in and we're going to cut 2 Woodruff keys there to depth. Alright, we laid the other shaft down here beside this one here, and we're using this to zero in where that Woodruff key is going to be. There's a little bit of room for air up and down the shaft, because the piece is longer than the Woodruff keys. And we already... Alright, we're going to call that 0 right there. Now, one Woodruff key in relationship to the other one is 3 1/4 inches. So we're going to get this first one, and then we're going to travel 3 1/4, and we'll do the matching. Alright, now we come in, we touch that on the top of our part. That's 0 and 0. Now we go ahead and we crank in half of the cutter. Half of the cutter is 1/8, so we dial that in, and half of the part is 3/8, so we 1, 2, 3, 75. All right, that puts that cutter center line with the shaft. And that's just off the table. Okay, we're going to verify that by slipping a piece of 1/4 inch key stock into the Woodruff key hole of this. Alright, and we're going to hold that down level, and I'll tell you what, it's pretty close to the same. Pretty close to the same right there. Alright. We're satisfied with that. We're locking our spindle. We're actually we're gonna set that to 0. So we're looking at about 5/16 on the depth there. 390. 390. Excuse me. That's 290. 290 on one and 5/16 on the other. So roughly about 300 thousandths deep. Alright, now we want the slowest speed possible, which is that one. And we'll go get our oil.